I'd introduce Luca. So Luca is the sales manager at Novacam. So we've been working with Luca quite closely over the past sort of year or so with the system that you saw in the videos. So what we're going to do is we're just going to run through the questions on the right hand side. Luca, I'll probably let you take charge of those.
Mm-hmm.
And yeah, anything else that crops up, we can go through together. All right.
Yeah, sure. So, good afternoon, everyone. Harry, am I asking the questions or are you?
So yeah, especially for the recording. So I'll go through from Rosie's first question, which is, what is the minimum bore size you can measure? And I think that leads into Claire Hillary's question as well. So what's the smallest ID that you could measure?
Yeah, so we manufacture probes down to about a millimeter OD diameter. So that allows us to measure IDs down to about 3 millimeters quite comfortably. We have gone lower than that as well, measuring 440 threaded standoffs. So ID threads that are quite small, somewhere in the region of 2.4, 2.2 millimeters ID. So it's possible to go down that low. Really depends on your application and if you're looking for more of an automated setup where you want a bit more space between the probe and part, or more of a laboratory setup where you have the time to do all the adjustments necessary so that there isn't a collision.
Perfect. So one of Rosie's other questions was, can you measure the part without rotating? For example, if it was too heavy. Hopefully we touched on it a little bit at the end of the video. But Luca, I don't know if you want to go over just the principle to, if we couldn't move the component, what we could do to measure those kind of parts.
Yeah, absolutely. I'll just share my screen if I may. So here, if everyone should see my screen. So with the bore inspect, it's a rotational probe, slightly different than the tube inspect, which is a rotating part and a stationary probe. But I'll just run this video just to show the principle of it. So it's as simple as it sounds. Really, it's a probe that rotates through 360 degrees continuously. We don't have to rotate and then spool backwards and then rotate in the other direction. It just has a continuous rotation. And then we typically marry this with multiple axes of motion, not just to measure IDs, but also more complex geometries as well. And so the light that we produce is collinear, so that allows us to also get into hard-to-access spaces like these EDM slots in order to measure, say, the width and the depth of these as well. So this is really kind of a quick level overview of the bore inspect system.
Perfect. Thanks for that. So another question is related to defects. So can the system be used to measure defects?
Mm-hmm. Yeah, absolutely it can. I know you touched on it on your video a bit more, but just to elaborate, what we can do is, sorry, I should have it here. So in addition to the point cloud files, which you showed, which are 3-dimensional files, we're also generating a light intensity map. So how much signal we're receiving relative to an XY position. And so you get this beautifully unfolded microscope-like image from which you could then discern striations, scratches, pits, indentations, etc. And then in addition to this, since all you see here is really just a black area that's inconsistent with the surroundings, you could compare visually what you see to a height map as well. And so that allows you to then correlate what's actually happening on your surface and how it's deviating. And so here we could see that we have some a pitting or indentation on one of the lands, whereas this bottom defect here, we have foreign debris or a body within one of the grooves. So it's possible to dislodge one versus the other one is more of a corrosion aspect to it. So all of this is acquired at the same time in addition to the point cloud files. So it does give you quite a lot of information to work with. to then drive your process improvement and understand what's happening within your products.
Perfect. Thanks for that. Question from Ashley. Can the system be used for measuring glass canisters / bottle balls, clear and colored glass?
No, absolutely. So we are an visual and optical method of measurement. So we do have applications to measure thickness as well. Right? So we have measured optical fibers, glass bottles as well, medical catheters, catheter balloons. So from this perspective, we could also include thickness measurements to the list of capabilities that we have to offer.
Perfect. Okay, so Robert's got quite a few questions, so we'll break them down individually. So the first one being, what is the spot size of the laser, the area that it looks for a single data point?
The spot size is only dependent on the optics and therefore the probe that we manufacture here in-house in Montreal. So we do have quite a bit of ability to tune the system to various applications as necessary. Generally, we're playing in the range of, say, most of the applications are 10 microns to 30 microns or 25 microns full width half max.
Makes sense. Hopefully
So,
that answers those ones. If there's any further elaboration you need on the questions as well, just drop it in the chat. And what we can do is we'll follow up on people that have asked questions to make sure that everything was answered for them. So if there's any further information you need, we can sort all of that. So another question from Robert is related to how does it compare to other roughness measurement techniques?
For contact roughness, it's we don't go down as fine. Generally, with the Microcam 40, the system that you saw there, the interferometer that was paired with it, we go down to about a 0.8 micron RA. We do have a Microcam 3D that is more for finer roughnesses that we could drive down to about 0.2 micron RA, but this also depends on the probe characteristics as well, as we do need quite a small light spot size and good control in terms of the focus of where we're putting the focus on the surface too. And so you can't always put the correct optics within a restricted area or space that you would need to achieve the small or roughnesses. What we do see kind of as a compromise with a lot of our clients is that they're using roughness as a proxy to measure defects. And so roughness is good if the surface is uniform, but if you're looking for discrete defects or discrete discrepancies within the surface, those end up being viewed more within a defect detection scan in which we're doing a very dense scan of the surface and able to then say, okay, well, this surface is dissimilar to this. So we could see changes between, say, areas that haven't been properly honed versus the initial machining pass or, you know, some wear measurements relative to the rest of the bore itself.
Perfect. Okay, so third question from Robert is related to what is the operating window for the roughness measurements. So what I will do for that one is when the recording is sent out for this, within the roughness section, there should be a little pop-up window within the video, and that describes where you can select the parameter of the roughness that you'd like to use, as well as being able to decipher or pick your cutoff lengths. Because obviously with the newer standards, you need to be able to move those around depending on the roughness of the material. So we need to be able to customize those. So hopefully that should answer that question within the video section. If you'd like to ask any more questions on that part, Robert, when we can go through that offline as such. Has it been used to inspect the gap between components in aerospace stacks before?
Absolutely. And I could probably show you an image here. Let me just find it. And so this is just a plain linear scan of a stack. And so from here we could measure the grip length, the distance of each stack, and the distance and the gap between each stack as well.
Perfect. Super. One of the question is related to, can it measure metallic burrs? So can we look at using the system to measure burrs?
Oh yeah. Depends on the size of the burrs, of course, and their location. But yeah, burrs are something that we have quite a bit of experience measuring here in our applications lab. We also have the ability of having angled probes. Just try to bring that up here. So I could go in with an angled probe into a space where I don't have access, and then also get data on the exit burrs within a hole as well.
Nice. Perfect. And the last one from Robert is, could it measure delamination of a CFRP?
If the delamination of the CFRP exhibits itself on the surface, since we are a line of sight measurement, then yes, you would be able to see the roughness and the gaps happening there, as long as the scan density is appropriately programmed.
Perfect. Okay. And the last question is from Rory. What is the limit? The limits? Can the machine check features such as roundness? So I'd focus on sort of the tolerances that we can work towards, and hopefully that should answer that question.
Roundness, typically to a couple of microns. Obviously, we're not reaching the levels of a roundness tester, but this is a non-contact point-by-point measurement system, and so we don't have all the I wouldn't say difficulties, but issues that you would have in automating and industrializing a contact measurement system where the styluses would have to be replaced. So it is a bit more robust and industrial in that regards. And we do work with our clients in terms of taking the measurements that they typically see done in the lab and then bring that closer to the machining process in order to close that metrology loop, so that you're able to extract those details to your SPC and also feed the details back into your machining center for automated offset compensation.
Perfect. Happy days. Hopefully that answers that one for you, Rory. So at the minute, there's no other further questions. Here we go. Is there any way of getting color? So is there a way that we can analyze color with the system?
As it is currently, unfortunately not. So we use a red laser for alignment, which is what you saw in the video, but we're actually measuring in the near infrared, so it's invisible to our eyes at about 1300 nanometers. Perfect.
Hopefully that answers that one as well. So there's no other questions and no one else typing. So what we'll do is we'll finish it there. If there's any other further questions that crop up, please don't hesitate to get into contact. Obviously, we've got our sales reps that some of you may be aware of, but internally, if you were to go onto the Sempra website, you'll be able to drop us an email. We'll try and get back to you with the information you require. So I just want to say thank you to Luca for joining us. It's an early start over in Canada for him. So thanks for joining us, Luca. And yeah, it's been a pleasure. Any queries, let us know. But thanks for your time, and hopefully speak to you all soon. Cheers.
Have a nice day.
Cheers. Thanks very much, guys.
Bye.